Okay, so now that we talk about some signals that involve in proliferation or ones that are involving different signaling pathways, and we are going to talk again about cell death, if you remember this signaling pathway, and now we're going to talk about the process of apoptosis. So these are the ones that are involved in cell death. So I'm going to start showing you a video, then I will make a difference between apoptosis and necrosis. And I'm not going to, we'll have an entire class to talk about this. So I'm just want to give you some background information. Start by watching this video that describe what apoptosis is.
Apoptosis is an important cellular process that allows cells to die in a programmed fashion. Apoptosis plays an essential role in growth and development, such as in the womb, where the fetal hand starts out as webbed, and fingers are formed through the programmed death of the cells in the web spaces. Apoptosis also plays an important role in removing faulty cells. For example, pathological apoptosis may be induced if cellular DNA is damaged beyond repair. In apoptosis, the cell is broken down from within by proteins called caspases. For apoptosis to occur, these caspases first need to be activated. Caspase activation can happen via two distinct pathways, called the extrinsic and intrinsic pathways. The first pathway is referred to as the extrinsic pathway because the initial signal comes from outside the cell. This pathway is often initiated by other cells, commonly by subsets of T lymphocytes. These lymphocytes have a surface molecule known as Fas ligand, or Fas-L for short. The extrinsic pathway is initiated when Fas-L binds to Fas receptors on the surface of the targeted cell. This sets off a chain of intracellular events that will ultimately result in apoptosis. The sequence is mediated by a Fas-associated death domain, or FAD. In the final step of the extrinsic pathway, caspases activate each other in a self-amplifying process called the caspase cascade. Apoptosis is then initiated as the active caspases begin the breakdown of cellular materials. The caspase cascade acts as a common endpoint for the second apoptotic pathway, known as the intrinsic pathway. As its name suggests, the intrinsic pathway is initiated by signals from within the cell. This intrinsic pathway is regulated by maintaining a balance between two sets of proteins in the mitochondrial membrane: anti-apoptotic proteins such as BCL2 and BCLX, and pro-apoptotic proteins such as BAX and BAC. In a healthy cell, the anti-apoptotic proteins bind to the pro-apoptotic ones, thereby blocking their action. But if a cell is damaged, or if it stops receiving survival signals, BCL2 and BCLX are blocked in turn. BAX and BAC are then free to punch a series of channels in mitochondria, allowing mitochondrial substances, such as cytochrome C, to leak out into the cytoplasm. The leaked cytochrome C binds to APAF1 proteins to create a compound that then activates the caspase cascade. Apoptosis plays a key role in growth, immune surveillance, and neoplastic development. In all of these processes, there can be abnormalities of too much or too little apoptosis. For instance, cancer cells survive and replicate because they are able to block apoptosis. Understanding the functioning of the extrinsic and intrinsic pathways, as well as of the caspase cascade, allows us to design targeted therapies based on better regulation of apoptosis.
Okay, so this video I found it very useful and that it summarized everything. Now you can understand more in detail the GNK pathway when they talk about the caspases, how they work, and they give you a little bit more of detail in a lot of concepts. Later, we will talk at the end of the class, not this class, at the end of the course, of about more things about apoptosis. So, uh, so last time in the previous slide, in a previous slide, I told you that the cells receive an stimulus from outside, and there is a changes in the morphology of the cells that end up in the formation of these babblings. Yeah, that is, and the formation of apoptotic bodies. So the cells will be recycled, and all these molecules will will be part will be phagocytized, or there will be many processes in which they will be recycled. Last time I didn't tell you something about the chromatin condensation, that is, it was covered in the video, but this was also an important step in the apoptosis, that the DNA changes a little bit. So remember, In apoptosis, when the cell is damaged or is not functional properly, it should be eliminated. And they show you how this process it happened not only during development, and they show you an example of the membranes between our fingers. So this is why some people can, if they don't have apoptosis, they will have membranes between the fingers, like the ducks, like those birds, or like any those birds that swim. So they just don't have apoptosis in that region. In our case, we have apoptosis, so this is why we don't have those membranes. Um, and apoptosis is not only important during development, but during our lifetime, as we will talk later in future classes. There is during all our life, there will be a constant balance between proliferation and cell death. And right now, some of our cells will be dying, and new cells need to be replaced, need to replace those cells. So this is not something that happened in the beginning of development, but it will continuously happen during our lifetime. So apoptosis is a very important process. We need to differentiate apoptosis from necrosis. Both are different processes, and here I'm sure that you'd recognize that this is necrosis. Yeah, so another type of cell that is called necrosis, that is due in many cases to cell injury. So well, here we talk about uh, the condensation and the forming, the bubbling of the cell membrane that produce these apoptotic bodies that, as I said before, they will be phagocytide. Yeah, here another cell is going to recycle those process. A different process involve the necrosis when enzymatic digester is needed to recycle the cellular content. So they use different as they are different process. They use a different cellular machinery. Necrosis involves swelling and rupture of injured tissues, where apoptosis involves a specific series of events that involve the dismantling of the cell content. Okay, so we'll finish apoptosis, and in the following video we will talk about the control of the DNA damage.